Hello folks, I'm Anupama Kate, presenting in behalf of my team Laiba, Somnath, Sunny, Rohan and Yogini for our internship project on forecasting gold price. For that we use Python and machine learning algorithms and models. Contents of my project are business objective, project architecture, data collection and details, exploratory data analysis, visualizations, modeling, evaluation and deployment. First of all, business objective. Data provided to us is related to gold prices. The objective is to understand the underlying structure in our dataset and coming up with the suitable forecasting model which can effectively forecast gold prices for next 30 days. This forecast model will be used by gold exporting and importing companies to understand the metal price movement and accordingly set their revenue expectations. What is significance of gold? We all know gold is a global currency. It is a good investment tool and gold price is always heading against inflation. It is stable asset. It has a history and ritual background all around the world in terms of jewelry, and no doubt it is a commodity to secure future for next generations. So, project architecture is like business understanding, data collection, data preparation, EDA, exploratory data analysis, then model evaluation and model deployment. First of all, data collection. Data is provided to us by authorities, so we have to find out what it contains. Our data contains 2182 rows and 2 columns, which has year range from 1st January 2016 to 21st December 2021. It contains two variables. First one is a date, which is daily entry date, and second is the price. This is how our data looks like. Next is importing libraries and datasets. We are importing required libraries to run Python, programming and models. The next is EDA, Exploratory Data Analysis. To explore the data, we have gathered its information, what is head of data, what is the shape of data, is there any null values present in the data. We have found out how many unique values in this data, is there any duplicates value in that, or and the answer is no, and describe the data. Then EDA visualization. We can see that there is increasing trend in this graph, and no doubt the trend is not constant, and the basic reason behind that is there is a there is a sudden increment after 2020. During 2016 to 2019 the data is fluctuating but in the fixed data frame, but after 2019 there is sudden increment in the price and also incremental trend above. This is happened because of in between this period there is a insertion of global pandemic COVID-19. So this may be one of the factor to increase the gold prices. This drastic increase in gold price after year 2022, and there is intermediate fluctuation in 2021. So this is time series composition, in which trend is slow moving changes in the time series responsible for making series gradually increase or decrease over time. In seasonality, seasonal patterns in the series The cycle occurs repeatedly over fixed period of time. In residuals, the behavior of time series that cannot be explained by the trend and seasonality components, also called random error or void noise. This is the visualization of mean of the data, mean of the values. We have taken mean of the price values and then plot it. We can see there is a trend in blue line and the dot showing the prices. So this is visualization. We can see that there is no constant direction of the mean increase or decrease. This is a mean line and we can just clearly see there is no increase or decrease near about the no fixed increase or decrease near about the mean. There is no trend, which is understandable as there might be many external factors involved in the price fluctuation. Then we have divided the data into 4 quartiles and checked the normality in the data, and we can clearly see there is no normal thing in this data. Then we have some scatter plot of price versus date. Then we have plotting the bar plot in which also we can clearly see in the log plot of price, the price is near about same up to 2018 or up to but after the 2019 there is a sudden incremental in the prices. In the pie chart also we can see contribution of price fluctuation is near about same in from 2016 to 2018 and near about 90, but fluctuations in 2021 and 2022 is performing greater part in this data. Then we have divided the data into months and then plot the box plot, and we can clearly see here during the month of February, March and April and also in August there is some increment in that and that month, so that we can the reason is obviously clear. There is a insertion. This is the period of rituals and marriages in India. So or in the January also rituals and marriages, and also in the month of March there is and also economic year starts from March. So this may be in this may be the main factors which affect these things. Then trends and seasonality in weeks. We can clearly see week wise there is no such fluctuations available here. So weeks does not play a weekdays or comparing the weekdays is not such a good part to explore the data. In the correlation plot of EDA, we can clearly see we have 4 parameters now: price, year, month, day and weekdays. So this price versus price style is showing, price versus price, year versus year, month versus month, day versus day and weekday versus weekday tile shows us that this data is exactly correlated with itself. But rather than that, there is no such a correlation between weeks and days and months with respect to each other. But there is a clear correlation between year and price, which is 0.88. So our part of interest lies between this area. Now using ADF test, we split the data. From the above ADF test, we come to know that data is non-stationary and we have to convert this non-stationary data into stationary data. So this is original series We have done over the partial correlation and autocorrelation on that. We can see the square root transformation. We transform the data into square root and then we have plot, and we can see that there is no such a part. This is no such a playing part in this. So we convert our EDA into HTML. We put EDA into HTML so that layman can also understand what is hidden inside that data. Now next part is modeling one. In model building, we have split the data into test and train part, which is basically less than 2022 data. We have put less than or equal to 2022 data. We have put it into the train part, and greater than 2022 is putting in the test part. So first of all, we are using ARIMA model. In ARIMA model, we are importing auto ARIMA libraries, and we can see the result, actual versus prediction. This is train value and this is actual value, but we are putting it into the test value, and we can see the prediction here, which is clear is related or near about the test data. And we have forecast the data for next 30 days, which we can see it like this. Next is ARIMA model. For ARIMA model, we are importing internal tools and APIs, and we can see an actual versus prediction graph, in which we can clearly see that the predicted value is far away from the actual test data. For the forecasting for next 30 days also, we can see it is far away from the actual data. So next two methods are halt winter, single exponential and multiple double exponential or multiple exponential smoothing. Here we can clearly see that this blue line shows the model. This blue line shows the model which is fluctuating and which is near about the mean of fluctuations. We are putting this model into additive multiplicative and multiplicative trends, and then trends and seasons, and then we can see we have put it in many ways, but still we can see that the predicted data is not correlated with the actual data. So next is EMA model. So in model evaluation, we can clearly see that in the ARIMA, single halt and multiple exponential smoothing, we can clearly see that when comparing these four graphs, we can clearly see that the trend of prediction is not correlated with the actual data. But in ARIMA model, the actual and prediction values somehow matches. So we choose ARIMA model. In mathematical terms also, root means square error values, that is RMSA value of ARIMA model is least as compared to all these methods. So we are putting ARIMA model for deployment. Next is deployment. For this deployment, we are using Streamlit environment, which we have created in Anaconda Navigator, and then launch. Actually, we have done this with both of these environments. with both of these environments, Jupyter environment also and VS Code also. So by launching this environment and running our file, we can clearly see the deployment app of gold price forecasting. So challenges we faced during this project is research on history of gold and deciding the model building technique. And we are overcoming how we overcome this challenge, as we are much not aware of gold prices. We have done a lot of research to find out gold price history. We as a team worked so hard to get the knowledge on previous year gold price data, which helps us to do project more efficiently. Deciding model building technique. As we tried so many model building techniques, every model don't have such a significant difference in the output. So we 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 are little bit worried about the output result that we got. But we again overcome this as a team. Everyone has worked really hard on this part, and we finally built a model that best suited for the data. This is it about my